All right. So a little review for you with some work deck examples to go along with your packet. So some factoring. So remember, as we go to factor, first thing we always want to check for is there a GCF. So as we look at this one here, we have a GCF of just 2. So we can factor that out. And so when we factor that out, that gives us x squared plus 12x plus 35. And so from there, we then can do our x. And remember, a times c goes on top. So 1 is our a, c is our 35. And then on bottom is 12. So then what multiplies to 35 and adds to 12? So we get 7 and 5. And then box. And so we get x squared, 7x, 5x, and 35. Looking for our GCFs here. We get 5, we get x, and we get 7. So then that gives us our GCF, and then x plus 5 and x plus 7. All right, number 2. So GCF this time is just 1. So we can go straight to make our x. 4 times 3 is 12. And we have negative 8. So it multiplies to negative 12 and adds to negative 8. So it's negative 6 and negative 2. And then so this time I'll do grouping for those of you who like grouping. And so we get 4x squared minus 6x minus 2x, and then plus 3. Then group. So here we factor out a 2x, and that leaves us with 2x minus 3. Here, that sign, we need to factor that out, so we just have a negative 1 that's there, and we're left with a positive 2x minus 3 now. And so then the 2x minus 3's are in common, so we can factor that out. You get 2x minus 3, and that leaves us with a 2x minus 1. Okay. Now continuing that, we then can now do this for solving. So again, always we're still factoring. So with that factoring, we want to look for our GCF. So in this case, we have a GCF of 2. This is 2n squared minus 3n minus 20. And we're just looking at the inside to factor. So a times c, so 2 times negative 20 is negative 40. And then we get negative 3. So what multiplies to negative 40 and adds to negative 3? So negative 8 and 5. Do our box. So we get 2n squared. Remember, all of this essentially comes from this. That negative 3 is made up of negative 8n and 5n, and then negative 20. And then we look for our GCF. So we get 5, we get 2n, we get n, and then here we get 4, and then we should check. So as we look, 2n times n is 2n squared, so we're good. N times 5 is 5n, so we're good. 2n times 4 is 8n, but we need a negative 8, so I'm going to make that 4 a negative. And then 5 times negative 4 is negative 20. And so we're good there. And so then that factors for us. And so we have our GCF, and then we have 2n plus 5 and n minus 4. That is set equal to 0. And so we now set each factor equal to 0. And you may have problems that are already factored like this, so we can just set those factors equal to 0. All the factoring work has been done for you. So here we get 2 equals 0. And then as we look at that, it's a good idea to kind of write that in case there was a variable. This one there's not, so that's not a case, so we can just cross that out. And then we get 2n plus 5 equals 0, and n minus 4 equals 0. Solve, so subtract 5. And 2n equals negative 5. Divide by 2, and n equals negative 5 over 2. And then here we add 4, and n equals 4. So then our two answers are negative 5 halves and 4. All right, number 4. Okay, so now one of the things that I didn't talk about in the previous one because it's already set equal to 0 is we need to get this set equal to 0. One of your goals is probably keep your n squared or x squared, whatever it is, for the variable positive. So I'm going to subtract 7n squared here. And that gives us 3n squared minus 5 equals negative 1 plus 11n. I'm going to subtract that 11n. There are no like terms on the left side, so that gives us 3n squared minus 11n minus 5 equals 0. Sorry. Negative 1. Add that 1 over. There's like term of negative 5, so we get 3n squared minus 11n minus 4 equals 0. Then from there, we look for our GCF. This one has a GCF of 1, so nothing we can do with that. So then we can do our x. So 3 times negative 4 is a negative 12. Our b is negative 11. So what multiplies in negative 12 and adds to negative 11? So negative 12 and 1. And then I'll do factor by grouping for those students who like that. So we get 3n squared. Our negative 11 is made up of negative 12n and 1n. And then we have minus 4. And that is equal to 0. So then we need to group. Factor out a 3n here, and that gives us n minus 4. Here we factor out a 1, and that gives us n minus 4. And that's equal to 0. We have the n minus 4s in common. So we get n minus 4, 3n plus 1, and then set each of those equal to 0. N minus 4 equals 0. 3n plus 1 equals 0. Add 4. N equals 4. Subtract 1. Divide by 3. And n equals negative 1/3. So there's our two answers for that one there. All right, factor by square roots now. So our goal for solving with square roots is we want to get our squared term by itself. So in this case, our squared term is just n squared. So I'm going to move everything else over. So I'm going to add 6. That gives us 3n squared equals 192. Divide by 3. That gives us n squared equals 64. Now to get rid of our square, we take the square root. That cancels that out, and we get n equals square root of 64 is 8. And then since we're solving, we get plus or minus 8. All right, same deal. We're still looking to get our squared term by itself. This time it happens to be x plus 5. But we're still just trying to get that by itself. So we're going to add 6 here. And we get 2x plus 5 squared equals 64. Divide by that 2. And we get x plus 5 squared equals 32. Take the square root. That cancels that out, leaving us with x plus 5 equals plus or minus the square root of 32. And then we're going to break that down. So two things to multiply. First thing that comes to my mind is 8 and 4. Could have done 16 and 2. You have some options there. 8 becomes 4 and 2. 4 is 2 and 2. Same thing with this 4. And we look for our pairs. So I have a pair of 2's there and a pair of 2's there. Each pair gets to come out, and then we have a 2 left on the inside. So that becomes x plus 5 equals plus or minus 2 2's, one for that one and one for that one, and then root 2 there. So we get x plus 5 equals plus or minus 4 root 2. And then to finish, we subtract 5. There are no like terms there, so we get negative 5 plus or minus 4 root 2.